I'm Jonathan Hamilton Solorzano. I work for the Office for Research Information Systems at UCLA, which is part of the Office Research Administration. We provide campus faculty, researchers, and graduate students with, but primarily faculty with a variety of services, primarily having to do with compliance and obtaining funding and recording what happens with the money that we spend. The federal government funds a significant proportion of the research labs at UCLA, and there are a lot of laws that govern what we can do with research, what's ethical, what's safe, what we have to do to show that what we're doing is ethical and safe. That's primarily the concern of the Office Research Administration. And because there's so much red tape and compliance and headache, and actually the national average for the amount of time that a researcher spends dealing with that instead of doing research, last time the National Council of University Research Administrators conducted a survey, was 42% of a researcher's time is spent doing non-research administrative activities. And so our goal with the Office of Research Information Systems is to provide them with as much automation and as easy-to-use systems as possible to keep that wedge as small of a piece of the pie as possible, get them down to 20, 30%, so that these really expensive faculty doing these really expensive research in these really expensive buildings are spending most of their time actually doing research, trying to find a cure for cancer, or a way to implant an artificial eye or something, or whatever it is they're doing out there. And prior to this, I've been doing this, working there for about 3.5 years. Prior to this, I worked at the Office of Research Administration at Stanford University, in much the same role. I work as both the manager of the infrastructure and operations side of our shop. We have a small data center. We have about 150 servers and providing service for our applications. And I also serve as the head of the application and architecture team, architecting applications to services. Slide five. So today's presentation, I want to talk a bit about application architecture and data architecture, but primarily about what our challenges are and challenges that that I run into in this role, in the central administrative role, facilitating these workflows on campus, and how we can and how we address these challenges. So there are a few business problems that this environment creates. As much as we try to make everybody's life as easy as possible to do research, there's still some new challenges that are created as we roll out more systems to them. And so I'm going to provide a kind of a high-level overview of some lessons learned and present you with some architectural models that we use and that are coming into more common practice, as well as kind of what the next steps are for this type of thing. So the basic need is, we have faculty, they're on campus, they're filling out some application about human subject compliance, they're going to do some human subjects research, which happens quite a bit, and they put in all this information about how many people they're going to enroll, what they're going to do, where they're going to do the research, what they're going to be testing. Great. Submit the application, go through this really lengthy compliance process, and then they sit down at another system and they have to input information about what kind of research they're going to do and what they're going to be studying and how many people they're going to enroll. They have to do this in 4 or 5 different places. And there are other systems that we run into that are like that. Another issue that we run into is that the systems the faculty enter this information to is somewhat opaque. So they submit, and then there's this black box where they don't know what happens for days or weeks unless they call. That was kind of a problem more a few years ago than it is today. And so we've been working also on kind of peeling back the covers and showing them what's happening with their applications, the compliance processes, and so on, in a user-friendly way that they can get access to it. But even when we do that, we give them this portal, which is a PI portal for them to log into. Sometimes it's 2 or 3 days out of date. It's very frustrating. They're like, if I open this application in this window, it shows this data, it shows some other data over here, what's happening. And another problem that we have run into is that several of our systems are old legacy vendor systems. Faculty are tired of using them, we're tired of maintaining them, but it's going to take us a significant amount of investment of time and resources to move off of them. So there are a few different steps architecturally that we have started to take to kind of help address and mitigate these concerns. First is separation of concerns. So I'll go into that a little bit more, and I'll go into each of these actually in more depth in subsequent slides. But one of the things that we have kind of done is we've kind of grown up as an application development shop. So we originally started with just a few people. 3, 4 people, just kind of building these one-off solutions or implementing these vendor products to fill this gap, and bringing their own perspectives and methodologies. And we had never really taken a holistic architectural approach and said, hey, you know what, maybe, your web page shouldn't directly be right into the database, on page refresh or whatever it is that you're doing. So we started to architect in a separation of concerns kind of in-tier services approach. Next is we've really taken a proactive step in trying to understand our business or our administrative users. We call it the business users, but it's the administrative department on campus that we work with. Understanding them and helping them to understand themselves better what they're doing. And also, we've started to build a canonical data model for their master data. I'll go into what that means. And then we're finally moving towards serving our data from a federation of sources. So a bit about separations of concerns. What we have currently, it looks like this on the left here, this current architecture model. We have application user interfaces that are consuming data from a variety of sources wherever it is most conveniently and readily available. And these are the databases driving our source transactional systems. So say WebIRB for given subject compliance, it writes to its database. But we pull that data into our operational data store nightly. Then we refactor that. We send that to Campus Data Warehouse, QDB. Some stuff from, not from WebIRB, but from our pre-award system and from some of our other systems that goes up to QDB. We have some other services that kind of do some things like determine how much money you've spent on your grant so far, what the projected date you're going to run out of money is. That consumes data from from the operational data store. And then we actually also have some application APIs that we wrap with our custom service wrappers to make it a little easier to work with. All of these sit behind this one user interface for us, these different pages of this UI. Sometimes one page will hit multiple of these. And it's not through any, it's not through any intention. It's just that's how it kind of develops. In some cases, we're even consuming data that's coming from here and here, and the same data that's going to the external data warehouse, we're consuming it through that pathway just because the person who happened to be tasked with that job had access to the campus data warehouse. They knew the data was in the campus data warehouse. They didn't even know that their own department was generating that data and had it elsewhere. It's like, oh, I'll just write a query against QDB and I'll put that in the UI, and my application is going to be down between midnight and 6 a.m. because QDB is, and oh well, and so what we're trying to move more towards is the separation of concerns, where we say, what, we're going to build a consolidated data access layer that can talk to each of our data sources independently from each other. And that is where we're going to use to drive our business logic and our application UI, and it's all going to go this way. Our business logic is going to include things like security and access control. It's going to be implemented in one place at one time instead of, here we have some low-level security, and in here, we have something that talks to DAX on campus, and another place we have our own system. No, we want to do it one time. We're going to do it here. We're going to consume the data here, and this layer is going to know where everything lives, and it's going to get it from the right place, and it's going to deliver it to the UI. Again, it was really just kind of our organic application development approach. We had a need. We moved as quickly as we could to address that need. A lot of times, there are actual federal guidelines associated with this, like you have to have this done by August 30th, or you will not get any more federal money after August 30th until you comply. So there's kind of some reasons behind this, stories behind this, but it was never really intended to be this kind of spaghetti logic. So this is the first step, kind of thinking about separation of concerns and really a service-oriented architecture as we build out these services. Next thing is understanding our business. One of the things that we learned through this approach and through particularly these transactional systems is our business has built a lot of their business logic around the constraints of the application that they have bought. We've built some custom applications for them. We've also purchased some vendor applications and deployed them off the shelf. And it's useful to do this if you have a vendor that's selling you something that you do. It's useful to buy it and look at it and see what they do, or to try it out and look at it and see what they do, because they're selling it to many universities. Everybody does research administration, but everybody does it a little differently. There's some historical reasons for this, which I won't bore you with, but long story short, I'll just say that Stanford's University Research Administration is governed by the Office of Naval Research, and UCLA is governed by the National Institutes of Health, even when we are funded by the same place. So we get an NIH grant at Stanford reports back on it to ONR. We get a naval grant here at UCLA, we report back on it to NIH. So It's kind of this Byzantine federal system. There's some crossover too, but what it results in is kind of every university has to do this slightly differently. And the vendors that sell products in the space have solved a lot of these problems already, but they may have not solved them as globally or universally as possible, or they may have solved them for somebody else whose processes don't match with what we need to be accountable to our oversight. So there's this logic mismatch. Also, there's kind of configuration gaps. So a lot of times our vendors just say, well, that doesn't exist in our application. You can't do that. We haven't built that functionality. You're just going to have to live with it. And so what we found is that our users both work with the applications and also work around them. In one case, we have a set of users that have built an Excel spreadsheet that shows that they plug data into in one end, and they go to the end of the sheet. It's got all these macros and stuff, and they take the data out of that, and then that's what they put into our web application, right? And that kind of defeats the whole purpose of having a web application. If they have to do that on the side while they're working within our system, there's something missing. And what that results in, too, is when we're in discussions with management about what are your business rules, what's your logic, it's really challenging to actually find that out. It's very tightly conflated with what the application can do. Oh, well, I clicked submit it and had it. Well, yeah, but what are you really trying to do? Who's responsible for it once you click submit? What does that mean to you to send this along? And so we really had to go through a very exhaustive exercise with them of defining nouns and verbs and saying, okay, who are the stakeholders? What are the swim lanes? What's happening here? Like a very comprehensive business process management discovery process. As we go, we've been working with them to improve their business processes and kind of diagram them, document them, starting at the lowest level of detail. Just okay, we as an organization, UCLA, get this. What do we have to do next? And then zooming into individual departments, stakeholders, and so on. And this may seem, somewhat far removed from data architecture, but what we found is that if we didn't start here with trying to understand exactly what our business was doing and what they were thinking about it, and they weren't thinking about it too, then we were building systems that were actually not reflective of what they were trying to do. We were building systems that were reflective of how they had seen it done the last time, plus some tweaks. And so when we started building our data models and figuring out, okay, what do we need to do next to make this thing work the way you want it to, we ended up having to start really far behind the curve. So somewhat, I guess I don't know if it's counterintuitive, but somewhat unexpectedly for us, designing a good data architecture really started with doing a lot of business process management. Then, we get to the nuts and bolts, kind of establishing the actual data architecture. Identifying systems of record is actually something that, one of the things that comes out of research administration is that there's a lot of overlap between what the systems do, kind of like blurred lines. And, again, we call the vendor, hey, we already have a system that does this, can you turn it off? Well, no, we can't turn it off, just ignore it. Okay, but then our users don't ignore it. Campus faculty, researchers, they don't ignore it. So in the Web IRB system, which is just about human subject compliance, there's also this whole section where they can fill out information about who's funding the study and what their contact information is and all of the stuff that they've already submitted to us, and it almost never lines up. In fact, we found that even on one of the simple questions in there, with a kind of a yes or no answer, it was wrong more than 50% of the time, which means they would have done better if they just flipped the coin instead of actually trying to answer it. But because that's not the system of record for this data. It asks the question, but it maybe shouldn't. And so when we are starting to look at our broader data architecture holistically, you can't take the naive approach and say, oh, well, I found the data here, so it must be right. I mean, that's the same problem we're running into here. Somebody was saying, oh, well, the fund data is all in the data warehouse. Yeah, and so is this other data. Yeah, but we generate that data. We send it to the data warehouse, So you really need to kind of inculcate this culture and make sure that you yourself maintain aware of what is the actual system of record for the piece I'm looking at here. And then, downstream in your architecture, you don't replicate that data, you key to it. So, we don't keep any person data. All of our applications allow you to define who a person is, what their name, email addresses, and all that stuff. I mean, it's kind of basic functionality. We just key that to their person ID at UCLA. And then we get the rest from QDB, because that's the system of record for people. And we don't want people calling us and saying, well, I did this in this system, and I updated my email address, and why isn't it working? Well, because it's sending to your UCLA official email address. If you want email to go anywhere, it's going to go there. Go and update it there. then, kind of considering our needs, we have run into a variety of use cases where we needed to proactively decide between different kind of degrees of normalization and data modeling approaches. So for transactional systems, we very highly normalize the data, third normal form, fourth normal form, make it as performant as possible, try to get these tiny tables, tiny indexes onto a solid-state drive. And that does not work at all for the systems where we're presenting data to our internal customer for reporting, for example. Because we have business analysts in our department who want to just be able to plug it into Excel or Tableau or something, and they don't want to do 74 joins to figure out what's going on. They just want to see it, in the table or in a view. And so what we found is that, in fact, while for our transactional system architecture, sure, you really want to denormalize, we found it's actually a lot more, with the price of storage as it is today, it's actually a lot more cost-effective for us to statefully persist duplicate data in the rows, just flatten the tables out, make it really easy to access both for our developers and our users, because the most expensive thing for us is the time it takes them to learn the system and look at it. I mean, you spend a lot of time looking at it, that's very expensive. Very cheap to just copy and paste the same row 1,000 times. We spend a few cents on a few extra kilobytes of data and we forget about it. So and that was a little bit, coming back from the days of database application development, that was a little bit surprising to me, being this really aggressive DBA, trying to squeeze every bit of performance it could out of the database. But nowadays, on our stand, we have terabytes of empty space. We might as well fill it in such a way it's going to save us time for all of our data consumers. Data versioning. So we've recently started using Fino on all of our systems that we're implementing as new transactional systems, as well as on all of the data that's going into our warehouses. First in, never out. We have is this record the real current data, yes or no, bit column on every table. We have, the valid dates. And now we can go back and we can look at any particular day and time for any of our systems, and we can look at the system's data at the end of that day. Only day granularity. We're not doing necessarily deeper than that for our warehouse particularly. But we found that this, proactively considering our data versioning and granularity that we're going to need to support our administrative processes has been really instrumental in allowing us to make really good decisions about what we need to do next with our databases, with our transactional systems. I'm not going to go too much into too more detail here, but just we assessed our data quality. Again, like I said, you've got to actually sit down and run reports and look at it. People are doing worse than a coin flip. Don't trust the data, and then, remote data suppliers and consumers, again, like I said, keying the data appropriately. If people are going to be keying the data to you downstream, you also just need to document and become aware of that. And then building the canonical data model. So this was, I think, the most interesting exercise that we've undertaken lately. And this is sitting down with our business users and, and with our business analysts and saying, okay, we have departments, we have people, we have these big Post-it notes on a whiteboard. Show me what you, how you do your work and what the system is like to do. How do you think about this? And we've actually learned that, in fact, some of our systems are conflating 3 or 4 separate concepts into a single table in the transactional system, a single thing. And so we've been teasing that apart, and it's been a very illuminating exercise for us because it's helping us to understand and simplify a lot of these Byzantine business rules. It was a really concerted effort, and it continues to be, to sit down with our consumers, even in some cases having them reach out to faculty and say, hey, what does this mean to you? So that we can build a view of the world that's internally consistent, that everybody can look at in one way and understand what everything is. And essentially it's just been a trial and error process. Again, sticky notes on a whiteboard. Okay, this is a grant. Is a grant a type of funding? Yes. Okay. And building out that tree and kind of hierarchical data model, or in some cases the star schema model, or whatever, that actually speaks to them and how they think about the data on a day-to-day basis. And we'll come back to that. That is for driving this architectural pattern. This is a federated data service that illustrates consuming different source systems, transforming the data, and presenting the data downstream. And the power of this service is that the only piece you ever need to maintain once you understand your business and once you have built your data model are these accessors. It is You already know your canonical model. You already know what the data should look like. And then you go to each of your data sources and you say, okay, what do I need to do to tease to tease this apart or mash it together until we get to what I know the data actually looks like. And so you build those against a common set of interfaces or a common interface. We're a C# development shop, so we use interfaces and just say, okay, this is the interface that defines our data manager. I want I'm going to have a method that takes, a person key and returns a list of all of their grants. I'm going to have a method that takes, a pair of dates and returns all of the grants that we've received during that date window. Great. That's the end of the interface definition. And then we build the accessors that actually serve that interface against their pre-award tracking system or against QDB or wherever that data lives. And as long as they meet the interface constraints, then our downstream systems don't have to care where the data came from. We can make that decision in here, and we can say, okay, you know what, we've got these different sources, we've got these accessors. We're going to decide at runtime which one we want to use for whatever purpose. So, for example, you can say, okay, I have an accessor for QDB, for my internal data warehouse, and I have accessors against the transactional system and against the applications API. First, I'm going to try to hit this for the most current data. If it doesn't respond, then this and then that. It's kind of a failed out architecture. Or you can say, well, I only want to hit the application API if I'm asking for data that's from today. Otherwise, I'm going to go to the data warehouse because I don't want to hit the transaction system. Great. So that's kind of a that's kind of a technical use case where you can make the decision about accessing the data from the right place based on what's going to serve your transactional system needs. But even cooler than that is that once you've built these accessors, you have built in effect a very robust, the cornerstone of a very robust system. Because all of your subsequent systems only need to consume your presentation layer of this service. And this is what lays the groundwork for that separation of concerns. You build your business logic up here against your canonical model. Doesn't matter where you're getting the data from. You never have to refactor your business logic. You can just say, okay, I know I'm going to get data. I know it's going to look exactly like this. These are the rules. For a single service example, this is just kind of an abstracted example of a system that we're looking at. We have users where they have a data access kind of user interface that we present them with, as well as an application user interface. And so we have, this application user interface is run by an application that has an application system, an API, and it's driven by a backend DB. We actually ETL that database into our local warehouse on a nightly basis, and we have a data service that consumes our warehouse and presents it RESTfully. And also, the application has a RESTful API. And we have our data management service, which is this piece here, sitting right there. And it can decide, okay, do I want to hit the API or do I want to hit the warehouse for this data access user interface? And then we want to hit the API whenever the API data is different than the warehouse, like it's from today, so that when the user's got this window open on this screen and this window open on their other screen, you're not seeing different things and calling us and saying, why am I seeing these two things not agreeing? Which one is true? So the downside to going for this architectural model is that it's extremely expensive to build up front. It's a lot of investment. You have to sit down with your business, your department or whoever for a long time to figure out what is your data model. How are you thinking about your transactions? You've got to implement transformations between your canonical model and the system that you already have. It's not very easy to do this. It takes time. There's a lot of really boring object mapping code to write. The savings comes downstream because all your data consumption becomes iterative. If you want to serve data to something else, you no longer have to answer this question, okay, how do I get data from this system to this system and match these up? It's like, well, I know, you begin to know your canonical model very well. You know where everything is. You put everything into it. You can find stuff very easily, and so you just have to build another connector to it and say, oh, okay, I'm going to flatten this out. I'm going to build a data facade or something, that represents the data the way I need it. And you can build your business logic against the canonical model, which is nice because then also you can later change out your transactional system, the source of all of this data, very non-disruptively compared to the current state of affairs. So I'll give you an example. I used to work at Stanford. We had a sponsored project tracking system that was built on a pre-RDBMS system in the late 1960s that was originally intended for collecting data from particle accelerators. And so we had this data collection system for particle accelerators, and somebody thought, hey, I can use this for tracking business workflow. And they did. We collected data against that system for 40 years. And it's a really Byzantine old mainframe structure. It's really challenging to even look at it and figure out what's going on. It's got 40 years worth of data in it. And now we're looking at, when I was working in Stanford, they were looking at taking the data out of that system and putting it into a database. Great. And they're looking at putting it into a new transactional system. Great. And there was so much data in there that it took, not counting the months of effort it took to map it out, but it took over 2 weeks for the data transform to just run on all of that data, churning and churning and churning on 40 CPU cores for 2 weeks to convert it. That is an extreme case, but more frequently, we run into situations where we have a system and we need to retire it. We need to spin something else up new. And okay, so we go through this exercise where we take the old system data, look at the world through some older, more fractured view or whatever, doesn't represent what we want to do anymore, and we go through a tremendous amount of effort to map it to the new system, which is great. And so we get rid of the new system. We just keep kicking the can down the road, and meanwhile, all of our data consumers, all of these applications we build like PI Portal, all of our other systems that consume the same data, we've got to refactor all of those every time, right? So it becomes a massive effort every few years if we ever want to change out our source systems to say, I've got to rebuild everything from scratch against a new system again and again and again. And instead, if we have a basic object-based understanding of here is what my data should look like, here's how I think about the data conceptually, and everything I have is built to that conceptual model, then you can extract any source system, throw it away, build a new system, build one accessor from your new system model to your logical model. And everything you have still works, because you basically just all you had to do was rip and replace this part, for one of your, for this one transactional system, and leave the whole rest of your infrastructure in place. So as we've been going through this effort, we have been taking iterative-based approaches. I mean, we can't drink from the fire hydrant. We haven't been able to just rip everything out all at once. Say, we're going to throw all this away. We're going to have a great separation of concerns, UI layer, business logic layer, data layer tomorrow. We've been kind of very gradually going through the process of implementing these new technical solutions as well as undertaking a cultural change. Kind of training our developers. Think about this way. Try to find the source key, kind of bringing these skills to our developers to listen. Just because you see the data here, that doesn't mean that's the right place to get it. And we've been doing that by taking our more junior developers and having them sit alongside some of our more experienced developers and kind of moving them around. So from project to project, instead of having the same people work on the same area of our business functionality, we're now separating them out and saying, okay, you're going to rotate a bit. We're going to take it on a project-by-project basis so that we can kind of cross-train these skills. There's some other technical considerations. We are going to be serving these data services to other campus customers. So right now, we're just using these to drive our own web front end that we're serving to campus from within our data center. But as the other nice thing about having implemented a RESTful JSON data model or data presentation layer, is now other campus consumers can consume directly from us if they need to without having us to go through QDB. And that's great if you have a use case where people need to get data the moment it's created. QDB is great for data tomorrow. We're getting these emerging use cases where faculty are submitting these very complicated applications that have tons and tons of data points, and then they have to go into another system 5 minutes later and do the same thing. So having to wait for the overnight refresh is not really an option for them. Again, we're trying to get that 42% of their time as small as possible. So we're looking into how we're going to harden that connection right now. For the one office we're working with, we're going to be setting up an IPsec tunnel with a certificate exchange in advance. Data authorization and access control are other things we've taken into consideration. I'm not going to go into detail on that. Underlying infrastructure, we had to stand up a server and storage stack behind these things. We've been looking at cloud services, but there's data security concerns. So we've been iteratively, as we've been bringing our application data services into this model, we've been looking at, is this the right place? Is this the right time to bring them to the cloud? So far, we haven't had any yet, but we're looking into that soon. And then looking forward, whenever you embark on a major technical architecture project like this, and you're implementing something, a new architectural model, you're going to have to redo it several times to get it right. So we know from the get-go we're going to have to refactor our data structures. We're going to have to refactor our access implementation. So it's just something we're planning for, which is budgeting into our development cycle time to go back and refactor what we've already deployed. And then the other thing is integration platform as a service and integration software as a service. This is something that's less relevant to what we do here. It's more for like if you're consuming massive commercial applications like Salesforce. But integration platforms as a service is a new concept that's coming out where vendors are starting to realize that there is this need for people to implement multiple systems from different vendors to be able to get them to all work in a common data space. Right now we're building this architecture from scratch. I mean, great, we have this architecture pattern, we have these artifacts, we know the direction we're going. But I think the way this looks nuts and bolts, is hundreds of lines of C# code, object-to-object mapping, web services, and using the entity framework to get the data out of the database, and just a lot of grunt work, a lot of this raw coding. And there are a lot of vendors out there that are starting to realize that people need to do this a lot now, and it's not really feasible for everybody to just hire 5 or 6 C# or Java developers and go build their own data transform implementations from scratch. And so if you're interested, if you have different sort of systems where you're thinking, you know what, 5 years from now I might want to be retiring the system, or these systems need to talk to each other. It's been a long-standing complaint we've had. I wouldn't necessarily start from scratch. I might go and look at integration platforms and see what's out there. Beyond the technical architecture, we've had people and process kind of organization work that's gotten into this. We've had to collaboratively define that canonical data model. We've had to establish agreements on downstream data usage with the people that are consuming our data directly. So for our own website, it's not a big deal. But when we're talking about providing data to other people directly, giving them access to our API, we don't want them to turn around and hand that data over to somebody else who's become a conduit for our API. So it's kind of raised some new administrative and governance concerns for us as to how we can make sure that people know to come to us if they want, say, research compliance data. Communicating change before we do it. So one of the other interesting artifacts that came out of this effort to build a data service around one of our systems is we changed that system a fair amount. We changed the questions it asks, we changed the available answers. And that's fine if we're the only ones looking at the data, but if somebody else is building downstream logic based on your data, and you have a question that says, have you ever done X, Y, Z? And then you change the question to, have you never done X, Y, Z? Yes becomes no, and once you tell them about it, their logic is going to break. And so we've, again, been exploring implementing governance around that. How do we make sure that our system consumers are going to become aware of this? And so we've started looking at things like API version. We're going to be serving data through this API, and the semantics of the data, not even the technical consumption of the data, just the semantics of the data are going to change. We may need to create and roll out a new API version that serves the data in the new semantic model, and the old data semantic model is left intact on the current version. And then processes, we've been worried about information security compliance, making sure that we adequately protect these interfaces, communicating change. Again, we now have a data change SLA, and increased governance on our source system changes so that we're kind of pulling back who's allowed to go into the system to make changes to the questions and answers we're asking, because now it's impacting this data architecture, this big canonical data model that we've built is going to break if anybody can just go into our transactional system and make configuration changes. And finally, we've had to build a process around keeping our data dictionary up to date so that both our internal and external stakeholders know, again, what the questions we have mean. So in addition to the technical work and thought and process work and thought that's done into actually building and extracting out what our data is about and building a model and communicating that data, we've had to come up with processes for keeping that information current so that we don't break or shoot ourselves in the foot. We don't want to get back onto that model where every 5 years we have to refactor our data from one system into another. And so it's just going to mean that we're going to have to shift all of that effort to kind of a small, ongoing, iterative effort to keep everything up to date. So key takeaways for this presentation. You need to understand your users and how they think about their data. You need to build your internal data structure and your logic against only that understanding. Again, we found that trying to build in lots of customization with vendor applications is usually more hassle than it's worth because we're stuck thinking about it from the way the vendor looks at it, not the way our users look at it. And so we built our separate internal data structure only against the way that our users are going to be consuming our data. We're going to be actively determining the degree of normalization and versioning in our data structures. So, in some of our data, we need daily versioning, and some we need per transaction versioning. And the data chain goes through 11 or 15 transactions a day. We need to have full accountability for what happens, and our data structure needs to reflect that. Then you can bridge, your specific concrete implementations, your vendor products, your homegrown systems to your internal data structure through a federated data service, and then you present your data from that internally consistent structure instead of consuming the source systems or source data directly. For further reading, the Information Security Office, if you are not aware, has lots of information about what you are allowed to share, how you have to secure the data at rest and in transit. Campus Data Warehouse, where some of our data lives, information is at this URL. And then there are a couple of Gartner articles. I believe all of campus still has a Gartner, all campus staff still have a Gartner subscription. So I found it to be very helpful when doing technical design work and architecture work for our applications to look at what the latest and greatest is breaking on Gartner. And so they have a really comprehensive, it's about a 70 or 80 page article on master data management, service-oriented architecture, and business process management, where those three come together. Some of the information from this presentation is heavily influenced by that work, as well as data integration decision point, which is a little bit more recent, and have been talking about the problem of data integration, presenting the federated data service model. In addition, they have a bunch of new research that either is coming out soon or has just come out about integration platforms that you can subscribe to and how you can use those. So again, if this is a problem you have, that you have all these different transactional systems, they're not talking to each other, you have users that want your data to just work, that should give you a place to start.